Hello, community. For us, it's a big pleasure to be here with you in this initiative, in this session about talking elevate security and observability with Cilium. So in the agenda, the amazing topics that we want to discuss with you. First of all, what is eBPF? Second, Cilium, how we can set up the environment in order to use Cilium, and of course, implement observability and security. So we can say that in this session, we have the theory part and of course, an amazing demo that we can share with you. So we are Fabrizio Sgura, my colleague, Chief Engineer in Veritas Automata. Fabrizio.
Hello, everyone. Thank you for being here. I am the Chief Engineer at Veritas Automata. I am specializing in everything related to orchestration. My background is related to network, container orchestration, Apache Mesos first before Kubernetes. So I'm already familiar with all the concepts and things that we are talking about today since the past experiences. And I'm really happy to share my knowledge and my ideas with you all. Thank you, Gerardo. Go ahead with your super presentation of yourself.
Thank you, Fabrizio. Okay, my name is, like Fabrizio mentioned, Gerardo Lopez. I am Principal Engineer in Veritas Automata. I love the soccer. I'm very familiar and lover about movies, barbecue, and other stuff. My experience is in different cloud migration applications, for example, to AWS, GCP, and of course, Kubernetes. Mauricio probably not mentioned that, but both are Cube astronauts. So we're very happy to try to give all our effort and all your knowledge with you. And with this demo, of course, and all the theory is fundamental in order that you can continue extending your knowledge about Cilium and Kubernetes. So let me introduce you with a little context. What is important, why in Veritas we believe in observability. So in today's landscape, focusing on security and network observability in Kubernetes is a paramount due to the exponential growth in container and microservices adoption in production environments. The inherent complexity of distributed architecture makes it crucial to safeguard critical assets and ensure visibility and control over communication between components. Enhance security and improve observability allow for identifying and mitigating potential vulnerabilities, as well as proactively detecting and resolving network and performance issues. This contributes to maintaining the integrity, reliability, and of course, availability of applications deployed on Kubernetes. So, what eBPF is? eBPF, or Extended Vertically Packet Filter, is a powerful and flexible framework within the Linux kernel that allows us for efficient and safe execution of custom code snippets within the kernel space. Originally designed for network packet filtering, eBPF has evolved into a versatile tool for various tasks. For example, tracing, metrics, monitoring, and of course, security enforcement. Overall, eBPF is a great technology that empowers developers and administrators to extend and enhance the capabilities of Linux kernel in a safe and efficient manner, opening up new possibilities for performance optimization, observability, and security enforcement. So right now we have different use cases in order that we can use eBPF, for example, in network, security, and of course, observability tracing. We have different tools, different open source projects that right now are taking advantage about this powerful technology. For example, Cilium, and with different SDKs in C++, Rust, Go. We have another project like Pixie, Falco, Catran, and others. eBPF is a revolutionary technology with origins in the Linux kernel that can run sandbox programs. It is a privileged context such as the operating system kernel. It is used to safely and efficiently extend the capabilities of the kernel without requiring to change kernel source code or load kernel modules itself. So in this image in the right side, we can see the kernel runtime. We can run verifier programs, maps, kernel helper in the API, and of course, we can have the different operating system runtime like Linux or Windows itself. We can get different security control, networks. We can apply network security rules. We can check the load balancing, the behavior of security, and other things that we can improve or we can probably use in order to make decisions. Okay, what is Cilium? Cilium is a powerful technology that allows us to potential the network and secure solution of Kubernetes environments. It offers advanced features such as layer 7 visibility, security policy enforcement, and network load balancing. Cilium uses eBPF technology, and so it means Cilium provides efficient packet processing and scalable while ensuring robust network security and observability. It enhances Kubernetes network capabilities and, of course, enabling seamless communication between microservices while enforcing security policies at scale. It is a beautiful diagram that we can understand better Cilium. Cilium has two components. First one, the Cilium operator, and second one, the Cilium agent. Cilium believes in the control loop. It is probably a trending technology, a different amazing technology that different projects and components are taking advantage in Kubernetes. It is the control loop or the admission controllers, or in this case, the operator itself. With this operator, or the operator itself has the responsibility to manage the different agents. Each agent is installed into the node. It means that the agents work like a daemon set. So thanks to that, the agents can establish all the different commands that the Cilium operator orders to do. In this case, like you are seeing, the Cilium operator receives the different information from the users or from the admins in order to implement the nodes, and operator sends the traffic or the configuration to each Cilium agent. And of course, the Cilium agent connects or creates a networking between each pod into the node itself. So it is a probably important component that you need to understand. Cilium operator manages the Cilium agents, and the Cilium agents is installed into every node in order to create networking, communication, and get metrics, traces, and other things for pods. Cilium enhances observability in Kubernetes environments by providing comprehensive insights into network traffic, security, and application behavior, thereby enabling operators to efficiently monitor, troubleshoot, and optimize their deployments. So it means that we can use Cilium for the following scenarios: network visibility, service discovery, rich metrics, layer 7 visibility, flow visualization, and of course, improve the security of our network or security network itself. So Cilium enforces the security and observability of network using different technologies. For example, in this diagram, we can see in the left side, Kubernetes. Kubernetes is sending different, or it's receiving different traffic from the internal or external network, and Cilium intercepts all the traffic, security, and network, and take this information of the security and network and create different we can see all the flow traffic in our network. We can export, thanks to Cilium, the metrics of our network to Prometheus. And thanks to Prometheus, we can use or integrate with Grafana in order to create diagrams and visualize the metric itself. And of course, we can continue improving the security established and for different network policies with the idea to enforce the security in our cluster. So with this diagram, you can understand that Cilium is important and technology that help us to create or to build a robust environment in order not only secure our cluster. It is important, but the idea is use this information in order to make decisions thanks to tools like HubWide and metrics itself. So, of course, probably right now you are excited about the explanation that I mentioned, but it is the time to see a demo. And for this demo, my colleague Fabrizio will create a show, an amazing demo for you in order that you can see how you can, first of all, set up the environment in order to use Cilium. Second one, how you can install Cilium. And of course, how integrate the different tools, like I mentioned, like Cilium UI, Hub UI, get metrics, and connect with Prometheus and Grafana itself. So
my colleague Fabrizio will help me to create the environment. So we want to recommend two technologies. First of all, if you want to work locally, you can use Kind. Kind is a good tool in order to create Kubernetes in your computer. Kind use Docker in order to simulate the nodes in your computer. It's so beautiful. So in this case, we are right now adding different images in order to work that. And the second technology is, we are not getting any promotion to say that, Rancher. So Rancher use RKey2. RKey2 is a good technology because you can specify in a YAML what CNI you want to use previous to create the container, sorry, the cluster itself. So, okay, let me get started with the demo. We have this script. If you see, bless you. If you see under the networking, we are disabling the default CNI from Kind. We are passing or putting the true value. It means that we want to create a cluster with 3 nodes, 1 node. You can create. We can create 3 nodes. One node is the control plane. The E2 nodes are worker. But the idea with this example is create a cluster, Kubernetes cluster, disabling the CNI. We execute. No problem about that, because at finishing the activity, we can pass you all the scripts if you want to run in your local. Right now, we're creating the control plane. We're installing the storage class and joining the worker nodes into the computer, and waiting a little bit what will happen. It's, of course, we'll create a cluster so quick with that. So if we clear the screen, so we will add it, or we'll add all the different image versions, previous version. Why? Because the idea, in order to respect the demo, we need to accelerate that. A beautiful thing of Kind is that you can reload images previous into the technology. It means that when you create things, the nodes will use the preloaded images and will create the things so quick. Right now, we are exposing or viewing the YAML that the cluster created. And so, waiting a little bit. All the images are preloaded into the Kind cluster. And so what does it mean? It means that in the next script, we will create, right now here, exactly, thanks Fabrizio. So if we run kubectl get nodes, you will see that the 3 nodes are not ready status. Why? Because it's pending the installation of the CNI. If you see the pods, no any pods about Cilium. So then all is impending, of course, mainly the core DNS, because core DNS needs the CNI in order to work. So in the next command, okay, Cilium status, Cilium has a CLI. It's beautiful, because thanks to CLI, you can create and run commands behind the scenes, communicate with the cluster, and you will see what is the status of the Cilium. In this case, errors, of course, because nothing is installed. In this command, we will install Cilium. Cilium, you can install Cilium so easy using a Helm chart. Right now, we are enabling the basic features about Cilium. We run the command, and thanks to the previous preloaded images, this configuration will be so fast. What is happening behind the scenes is happening. Maybe you can run other commands in order to see, get notes. Yeah, right. If you run the command, you will see the start ready. Thanks that all the nodes are ready to use. If you run the command again, the get pods, you will see we have 3 pods, 4 pods, Cilium with dash some specifically definition. If you please run with the dash O wide in order to see what node. Wide, W-E, okay. Okay, Cilium status, you will see. Can you go up, please, in order to see the Cilium status? Okay. If you see, or run again, clear, please, and Cilium status again. If you see, okay, right now Cilium is okay, the operator is okay, different add-ons are not installed. For example, whole relay that my colleague will enable very soon. But important things, deployment the Cilium operator, desired, ready, and available pods. Cilium is checking that right now the operator has installed 2 pods. Daemon said the Cilium desired 3. Why? Do you remember that I mentioned at the beginning why install 3 pods about Cilium, the Cilium? What is the answer? Why? Daemon said. Appreciate. Excellent. Thanks to Daemon said we have 3 nodes, and we installed 1 per node. And that's it. It's Cilium operator, we can see all the information, Helm chart, image versions, and that's it. So it's so easy to use, but of course, it is the beginning. My colleague will explain more about observability and security. And so, Fabrizio?
I will run commands because I like to do that. And I know that you like to see. So I will use this ice cream. I hope that you hear me. Can you? Yes? So we installed the kind cluster. Now it's time to go for setting some Prometheus, Grafana. What we will do, we'll create dashboards or show dashboards that we previously installed because Cilium is instrumented for observability. So at this time, like Gerardo started with the cluster, I am going to add more commands. And for this, I will comment this Helm command that will install initially the Prometheus Grafana. We have a gist here that is in our repo. All of the scripts that I'm using here, they are available in a repo that we are going to share with you as soon as you add us to your LinkedIn, because there is a price to pay. So, and it's shareable, so it's a gist that we have. Everything is working. Basically, the 00 are the scripts that are installing all the kinds and similar. It's ready to use. It's something that is working almost perfectly. So I will run that 03 script. Then I will run this one. I'm using a modified version to show you colors. But basically, this other command that is enabling the relay for the Hubble UI, so you will see that we can instrument and see in the dashboards and in Hubble UI things that are happening. The idea is to install this Prometheus stack, so it will use the content of the previous script that I showed you, and then the enabling the service map, that will be something we will use to see the output in Hubble. After completing this part that is related to the service map, we can port forward the Grafana. I will just show you that the pod should be running here, otherwise we fail something. In the monitoring namespace down there, there are Grafana and Prometheus available, so we have our observability embedded in kind. That is always a good point to learn how these tools are working. So we installed both Prometheus and the service map. Now it's time to do something that is the port forward of Grafana. We can see that here I have the command ready to gain time, but basically we are going to expose the service endpoint that Grafana is creating with a port forward on the same port 3000. I left that for visibility. It can be omitted, but really it's something that everyone will appreciate. And I should be able to run a browser somewhere. Let me check if I can find the browser to have it on port 3000 and share with you the output of Grafana as we prepared previously. So I'm going to put Grafana here. There is no trick. It's really the Grafana that I installed. As you can see, it's running on localhost 3000. And we will see that we already have tools that are able to provide us some metrics. So if we go here, this is already embedded in Cilium. So you don't have to bother about building your dashboards, querying the data, just installing Prometheus and sending everything. We can scroll down. Probably it's not really readable at the moment, but there is a lot of metrics related to eBPF, to the network itself, and many other informations that can really be useful when you are troubleshooting and you are being not just a DevOps, but also whatever you are doing with the CNI, BPF, whatever. As you can see, it's a lot of data. You just have to get familiar with that, and it could really surprise you. A part of the Cilium metrics that we have here, there are other dashboards related to the Hubble UI. We will see that the UI is something that is coming on after running a command. And you see, it's very useful. So I will not enter the detail of all the dashboards that we have here, but as soon as we use the stack that we created, it will be filled up with a lot of information that are obviously very important for each one that is working on this kind of detection. So if we come back here, now it's time to expose the Cilium Hubble UI. I will use the typical Cilium Hubble UI command because it's probably the faster one that we can use. So I will switch terminal here. Cilium Hubble UI. It should open something if I have no typos. No, it's okay. I will share with you the screen of what it opens. So it's a primitive interface. They are working to improve the content here, but basically we have all the namespaces that we can query. And here you will see that there are the components that are running and a status that is interesting because we will see in the next section that is related to security. I will be very brief on security because we can do a lot of things with the rules that you can use for layer 7. What? Yeah. So I can enhance the screen, but it's not something that you can view more. I can do the Control+, but I think that really it's something that you can experiment downloading the scripts. So the content here basically of the Hubble UI is giving us a situation of what is happening across the pods that are running inside the cluster. Are you familiar with Hubble? Someone that is familiar? No one is familiar, so you are. Cilium generally started with Hubble embedded. It was the initial idea for giving visibility to all the things that were happening among the different pods running inside the Kubernetes network. At that point, they didn't enhance that a lot, but it's still a valid option to filter out what is happening in the column where you see the green. When we will run the commands to query a specific rule that will be forbidden, you will see that there will be a red one, or we can also use the Hubble observe commands using the Hubble CLI, but for the moment, let's leave it as it is. And let's go for installing a pod. Now I will be using another one, so this one, and I will install a pod that is just running Nginx. Oh, pod. Yes. So let's see what it is. These pods, this script, is just installing the classic pods that you have in the Kubernetes documentation. I kept it easy to read for that reason. And I will also use a policy. Initially, let's go for the Kubernetes one, this one. So if you are familiar with network policies in Kubernetes, you see that here I'm using a classic easy one, so I am just saying that I'm allowing ports 80 and 443, and I'm also allowing DNS traffic. The difference that I want to show you at level 7, it's very simple, basic. You can do much more things with rules on the HTTP level. So in example, you can filter on Nginx the route to a specific page. If you have the index.html and you want to see it, but not the about.html from specific filters that are related to labels or annotations or other strategies that you can find in the Cilium documentation related to the rules, it's really flexible. What you can do in Cilium, you cannot do in Kubernetes policies. So if we use this, let me see, because I don't see what I'm writing. So, tickets, Cilium, policies, yes. This is the difference. As you can see here down, I'm specifying only the endpoint of google.com that is queryable by the DNS. So after the testing, we will not be able from that container to run a query to another endpoint. That means that I will be able to filter at level 7 the application layer for querying a specific DNS without blacklisting it in another way. This is not possible in network policies, so it's a big difference. As I said, you can do that on the HTTP level. You can see here that there is a specific DNS reference in the list of YAML. I hope that you can see the characters, but probably not. Let's see if I can get bigger. Not that much, but I want to show you a specific entry that is describing the ability of using the kubedns for that port, and down here you can see that we have the DNS entry here. So I can specify the effective name of the endpoint that I want to query. Now we created the pods of Nginx. So what I will do is run in a couple of commands. But before of doing that, I will show you the commands. So we will use the classic Google is responding, and we will also query another endpoint that is familiar to everyone. We will use Microsoft. It is responding. At this point, I will apply the Kubernetes policies. Nothing will change. It's the same policy translated to Cilium later. So I'm applying that policy that was the first one that I showed you. And you will see that Google will answer, Microsoft will answer too. Now let's delete the Kubernetes policy. So I can use my specific command line. Oh, yeah. We deleted that one, and we apply now the other policy that is the Cilium policy, NS, because it's based on namespace. I forgot to comment that this policy is a specific of the pods that I'm using for Nginx here. So it's a pod called HTTP test namespace and Web Nginx pods. At this point, I will run again the two queries, one to Google. You remember that should work. And, oh, not answering. But look at the message. It's not a curl pending. It's a cannot resolve host. So it is acting exactly on kubedns. It is not resolving for that specific host. Saying that, we could look at the browser where we have these specific entries. And here we see that in this case it is still forwarding. Probably I need to refresh this. Or maybe I will use the Hubble UI, the Hubble observe command, because for this specific thing, we will be able to see a red login line. So let's go here. Red login line, let's see. Now, you see that here it's full of green forwarded messages. If I go to call again the commands that we were using previously, so I should have them saved in this terminal, I can use them. No, I will open another terminal. It's a little bit. And I will run the two curl that you saw earlier. After some time, here, it should not show, it should show something that is traced. So not forwarded anymore, but traced by something that is in color of brown. That means that the behavior is not forwarded anymore, but it's sent to trace because it's observed in the previous dashboards. All the things that we did now are available, obviously, in the Grafana interface. That should be still available here down, or here. And we should be able to see a lot of information related to the tracing and the activity that we did on the Cilium metrics and capture. You can see that data has been filling for all the time that we were effectively running commands, and it's confirming that we can observe what is happening on the network. So saying that, I think that we completed the part related to the operational demo. So how you can do to create these Cilium policies for network. I've been using the editor that is available online by Isovalent. You can go to the page and you will see this is not something that you can run locally at, as far as I know. I have not been able to do that, but on the site of the Isovalent company, you can run this specific interface, a page, and create your own rules. They will be available here as a Kubernetes policy, network policy, and as a Cilium network policy. So I decided to include what was the same YAML files that I used and I generated here. As you can see that in this case, it's very visible and easy to use. If you go there and you are familiar a little with the namespaces, the isolation and similar, this will produce an output here down that you can copy paste in your cluster and do the same experiment. So thank you guys for watching at our presentation. I hope that you enjoyed the demo. It was almost self-explanatory, so probably you will have a lot of ideas now, but you also should have comments. So please leave them in the related comment section, because we want to know from you, know your impressions, your opinions, and we are also very happy if you want to cooperate with us in developing something on this topic. So here you have our QR codes. If you want to get in contact with us, it's for whatever you think you can enjoy sharing with us your knowledge or learning from us something that is related to Cilium, observability, Kubernetes operators, and whatever you feel you want to ask and to communicate with us. We are always very open to have conversations on the social networks.
Thank you, Fabrizio. Thank you so much, all your audience. Appreciate the time. And of course, in Veritas Automata, we are very proud to continue innovating in different technologies, for example, Cilium and other stuff. Like Fabrizio mentioned it, we are very open to receive your questions and, of course, very happy to answer them. So thank you so much again, and see you soon in another webinar or session sponsored by Veritas Automata.